Welcome friends, I'm new. All game projects have to deal with performance issues. Budgets get blown, frame targets are missed, and FPS tanks. Today's video has two parts. First, we're going to look at Unreal's main profiling tool. Unreal Insights is super powerful. I'll show you how it works, and I'll teach you how to diagnose and fix perf problems in your game. Second, we're going to look at a real-world example. I've got a nasty perf bottleneck in my time rewinding project. Why is my game running at 20 frames per second? We're going to profile it to find out, and then we're going to fix it. Let's get started. Unreal Insights and tracing functionality now live down in the bottom right of the editor. If you're in an older version of the engine, you'll need to look around in the Tools menu. To launch Unreal Insights, we click on Trace and then go to Unreal Insights Session Browser. This will pull up the session browser, which shows all of the traces that we've captured. If we've never captured a trace, it's completely empty. To capture a trace, we click the button next to the trace menu to start tracing. That will turn red, which shows us that we're tracing. And if we look at the session browser, we now see that we have an entry, its status is live, and the file size is rapidly increasing. I'm going to go ahead and stop tracing before I look at my actual trace file. With that done, we can double click on the entry, and this will launch Unreal Insights. The Insights application shows us a ton of performance information across a bunch of different panes, and we will go through everything, but we're mostly going to be looking at this timeline view, or this timing view here in the center. Within the timing pane, you can zoom in and out by using the mouse wheel, and you'll notice right away that my editor has been running for quite a while because I went and got lunch and left it up. You can pan left and right by clicking and dragging, and you can zoom back in by scrolling in. Within this view, we have a bunch of different tracks. So at the top here, I have a GPU track, I have a track for my game thread, track for the RHI thread, the render thread, a bunch of worker threads, basically every thread that is running in my editor process. And for each track, we have a flame graph. So if you've never used a flame graph before, it basically goes top to bottom. And we can look here at the top and we can say, okay, we have a frame on the game thread. Within that frame, we ticked the world, we drew the viewport, slate ticked. That slate tick called slate draw windows, which turns around and called slate pre-pass, so on and so forth. So we can basically drill into a bunch of deeper calls. And as long as those calls are instrumented, we can see what they were doing and how much time they spent. In this top pane, we have timings for all of the different frames in our capture. The bigger the bar, the longer the frame. So if I wanted to look at this one fat frame, I can see it took 52.5 milliseconds, which is about 19 frames per second. I can left click on that to jump to it. And then if I press the F key, it's going to focus my timeline view to look at that frame specifically. So here I can see I actually spent 26 milliseconds pumping Windows messages. This is probably, well, I don't know what was going on there. I would need to drill in, but this is a really long frame. Along the top view of timing, we have a timeline, which is the time since the process started. We have a bunch of drop downs, which allow us to turn tracks on and off. So if for some reason I didn't want to look at, say, the game thread, I can just turn that off and turn it back on. Note, for something to show up in this list, I have to be capturing it. And we'll talk about how you configure what you're capturing a little bit later. The CPU, GPU menu also gives you groupings to filter. So if I want to turn off all the background workers, I can make them disappear like that. Other has some additional things that we can look at. Plugins has some other special things as well. But basically, this is just allowing us to turn things on and off for filtering. Another hotkey that is super useful is you can tap C to toggle between full view and compact view. So if I wanted to get a compact picture of everything that was going on, I can tap C and you can look for basically big chunks of color that might be interesting to drill into. And to go back to the full view, we just tap C again. In addition to the timing view, down at the bottom here, we have a view of logs and any important events. And if we double click, it will take us to that position in the timeline so that we can drill in. Over on the right, we have counters and timers. I find timers are generally the most useful. If I want to look at what happened in a frame, I can click on any of the tracks in my flame graph, that will select it in the timer view. I can look at inclusive and exclusive time, and I can also get a full picture of who called whatever my selection is. So that's callers. We can see here that engine loop tick called frame, which called slate tick, which called slate draw windows, which called slate prepass. And I can also look at callees, which is everything that the thing I have selected calls. In this case, slate prepass has widget invalidate called 14 times, but these timings are all tiny, 4.5 microseconds. So there's a whole bunch of stuff going on in slate prepass that isn't instrumented. And if I wanted to investigate this, what I would begin doing is instrumenting that code path and seeing the details of what is going on. A couple other cool things that we can do here. I can take a snapshot. There is a continuous running buffer in the editor, and when we click this button, it will snap that buffer and create a trace just with those details. So this is useful if, like, let's say I'm playing the game, I have a big perf hitch, but I wasn't actively tracing. I can take a snapshot to see what was there and then, open it up just like our first trace, and we could see what was going on. Few other things. Tracing, there's a whole bunch of different channels that we can choose what we want to look at. Right now, I am using the defaults, so CPU, GPU, some regions, bookmarks, some other things. While a trace is running, we can capture bookmarks and screenshots, which I'll show you. So first, let me do a bookmark, which I can do from this menu, and I can also do a screenshot from this menu or press Control plus F9. I'm going to stop my trace. I'm going to come back to the session browser. We're going to look at our most recent trace. And on this timeline view, once we get back to where we were, you will see, hey, there's a bookmark here with a timestamp, and that will also show up in our log view here. So that was when I pressed that bookmark button, and that gives me a clear visual indicator of what was going on there. I also have the screenshot right here on this timeline. So if I hit a bug or a performance issue and I wanted to take a screenshot so that I could remember what was going on at that point in time, we can do that with Control plus F9 while tracing. And similarly, that is also down here in our log view. So this allows us to really explore and get a full view of what Unreal was doing. And we can look retroactively, we can make changes, we can measure things over time. Other things that are useful to know. Running in the editor, we have a whole bunch of stuff running that is not our game. If we want really representative perf of just what our game is doing, we can either build, cook, and package, and then run Unreal Insights against that, or we can run against standalone mode. In both cases, what we need to do is pass an additional argument as a command line parameter. The structure of that command line argument, I believe, is -trace equals default for what I was capturing before, but you can also provide a comma separated list of arguments like CPU, GPU for the individual tracks that we want to capture. So I'm going to try trace equals default, and then I am going to switch this to standalone game. We're going to run that, and with any luck, we should see that session pop up, and we do. So right here, I've got Unreal Insights running. I also have the game coming up. My game is now up. I've lost my mouse. But you can see as the game runs, we are capturing a trace just like we did in the editor. But now it is just my game running. It is not any of the editor because we launched in standalone mode. So that is pretty cool. When we close the game, we will see the trace stop. Now let's look at a real world example. I've been prototyping a game with time rewinding mechanics. The way this works is each actor has a component that keeps track of its transforms and other state over time. When I rewind time, I simply play that state back in reverse. If you're interested in the full details, I have a whole video on it, but that's the gist of what's going on. I also built a debug visualization feature that allows me to see all of that state. Unfortunately, when I turn it on and a bunch of state has accrued, my frame rate absolutely tanks. I'm really abusing the debug drawing API. When I was looking at fixing this issue, I was actually really surprised about why it's slow. So it's a great example of why profiling is important. To figure out what's going on, I started by instrumenting my code. I added bookmarks, which again gives that little text visualization in the timeline view of Unreal Insights, and by adding CPU profiler scopes, which will show up on my flame graph. So I've got a bookmark for every time I turn my snapshot visualization on and off, which is that debug feature. And I've also got a bookmark whenever I begin or end a rewind. I've also gone through and instrumented all of the individual functions in my component so I can confirm that I understand why things are slow. I was expecting the slowest part to be in debug draw snapshots because what we're doing is we're going through all of that state that we've captured. We're calling draw debug point over and over and over every frame, and draw debug line, connecting all of those points over and over every frame. Here is what the profile actually looks like. Exactly as we expected, the moment we turn on the debug visualization, our frame rate tanks. The density of the work that's happening in our flame graph goes way down. And on our frame timings, we can see that we go from running around 200 frames per second to dropping all the way down to 10 frames per second. If I select one of these frames and press F, we can drill in and see what's going on. The total time on the game thread is about 110 milliseconds. Interestingly, most of that time is spent here in game thread wait for tasks, about 90 milliseconds of that 110 milliseconds. The rest of the time is being spent ticking our rewind components and calling debug draw snapshots, which is what we expected to be slow. Some of these calls are up to 2 milliseconds for a single actor. This would be completely unacceptable in a real game, but the 14 milliseconds we spent ticking does not explain why is the frame 110 milliseconds long. My original intuition was I'm going to come into debug draw snapshots. I'm going to, kick the can down the road a little bit, not really optimize this very hard, use the lifetime properties on those APIs to make less calls every frame. But this is a pretty good hint that that's not going to work. And the reason that's not going to work is the way debug draw point and debug draw line actually work is they write down some state, and that state actually gets consumed as part of rendering work. And in fact, if we scroll down and look at other threads, we can see that background worker number 14 in this case is where all that work is happening. 94 milliseconds of that 110 millisecond frame is happening on a background thread. If I shift to the compact view and zoom out a little bit, what we will see is there are these big blocks of work happening on various background threads. And that's because the renderer is doing a bunch of background work that is moving around every single frame. But this is really what the bottleneck is that is causing our frame rate to dip so hard. Unfortunately, the details of what we are doing there is not instrumented. My next step was to go into the engine source code, add some instrumentation, rebuild from source, repoint my project on top of that. And this is probably overkill for the common case, but I really wanted to confirm that I understood what was going on here. Here's what a similar profile looks like with that instrumentation added. We can see that all of the time is spent in draw debug primitives, and underneath that, we are calling some functions in fbatched elements. So drawing points, drawing thick lines. In the code, if we just scroll through, there's a RDG event for adding debug primitives that then calls into the element batcher. There is a whole bunch of logic that is running here in fbatched elements draw, and this is where all of the actual work for debug drawing is happening. So our current approach is totally doomed. I had to do something completely different. Visualization V2 grand reveal. Note we're running at a locked 120 frames per second. When I turn the visualization on, we remain at a locked 120 frames per second. The way I solved this performance problem is I moved off of the debug drawing pipeline entirely. I made a new rewind visualization component that derives from the instanced static mesh component. There's only one function here that is really important. It's set instances from snapshots. And I refactored my debug draw snapshots function on the rewind component to simply turn around and call set instances from snapshot on the visualization component. The way set instances from snapshots works is instead of running through all of the state snapshots and directly calling debug drawing functions, it instead runs through those snapshots, samples them, pulls out a bunch of transforms based on how much time has passed and how much movement has occurred since the last snapshot. It then does a little bit of math to adjust the rotation of those transforms so that they look at one another. It then updates all of the instance transforms on that instance static mesh component parent. At this point, all we're doing is using the standard Unreal mesh drawing pipeline, which is very good at drawing a lot of meshes. And for the mesh, I just used Unreal's modeling tools to take a torus and an arrow and make a very super dumb, simple mesh. Kind of looks like a Sonic ring, but it makes me happy. Here's what the profile looks like with the new solution. The main thing to notice is that our frame rate remains completely locked at 120 FPS. We don't have a big degradation even when we turn on the timeline visualization. You can see that's happening because our bookmark is still here. If I pick an arbitrary frame and drill in, what we're going to see is that that frame time is way down. Total frame time now is on the order of about 9 milliseconds versus the 100 milliseconds that we saw before. And the time we spent ticking also went way down. Previously, we were ticking for about 13 milliseconds, and some of our biggest offenders in the rewind component were taking 2 milliseconds each to tick. Now they're running between about 10 and 20 microseconds on a fat one. Most of this is still in visualized timelines. If I wanted to have an absolute ton of actors, there are some pretty obvious things I could do to improve this further. But for now, our total time ticking for the entire frame for all actors in my world is less than a millisecond. We have plenty of frame budget left, and we are no longer spending 50 to 100 milliseconds on that debug draw primitives RDG pass. So this is solved. As usual, all my code will be up on GitHub. Feel free to do whatever you want with it. That's all for today's whirlwind tour of Unreal Insights. If you found this useful, you'd be doing me a solid by doing the standard YouTube engagement shenanigans. Slam that like button, ring that bell. And if you want to learn more about my Rewind project, definitely check out that video. Until next time, be kind to one another. Peace.